Warning: to avoid fire, shock, or death, turn off power at circuit breaker or fuse and test that power is off before wiring.
With our low voltage aux sensors, they are designed to be basically installed and configured right in the field. What comes with the product, you get the sensor, and then you also get some mounting hardware that can be used. Generally, this is going to be surface mounted, and then you've got your low voltage wire connectors that'll go directly to your power pack. Also included, you've got different masking devices if you want to block off certain areas for the PIR. It comes with a 180 and then also one that can be customizable to cut out to whatever you want to block out in the room. As I mentioned, these sensors are designed to be configured in the field. To do that, you'll remove the cover and it'll expose different controls underneath that cover. You have the ability to adjust the PIR, which is the red arrow, and this can increase or decrease your range. Same thing on the ultrasonic side. If this was a PIR only device, you would only have the red knob and not the green, but this is PIR and ultrasonic. You also have the blue knob that is going to be used to configure your daylight level for your ambient light hold off if you want to enable that feature. And then lastly, you have a knob for the timeout, which can be anywhere from 30 seconds up to 30 minutes. You also have a series of dip switches under the product or under the cover that can be used to put it to different operating modes, including test modes, auto adapting, etc. All these details are listed on the instruction sheet. Power packs are essentially relays that are going to open and close based on what the aux sensor tells it to do. We have several models out there from basic that can do auto on only, up to models that can be used for auto on, manual on, and have daylighting control as well too. This version here is an OPP20-0D2, and this one can be used for auto on, auto off, and also manual on, auto off, as it has a wire for a local switch input. You have the line voltage wires on one side, and then you have the low voltage wires on the other side. The line voltage wires will be connected directly to your incoming line voltage and then also to the fixture, so the relay inside will open and close to turn the fixture on or off, and then your low voltage side will be connected to your aux sensor, potentially a low voltage switch, and also a photocell too. So depending on what those sensors see and do, it'll tell the power pack whether to open or close that relay, which will turn the lights on or off. Next up is a photocell, and we have switching only and also dimming photocells that can be used for full daylight harvesting. This is the dimming model, ODC0P-D0W, and you have some low voltage wires here that we'll cover in one of our diagrams on how to wire that up to a system that uses daylight harvesting. Under the cover, you have different controls that you can use to manually control that light level, and then also the fade rate, which is going to determine how quickly the photocell will respond to changes in ambient light levels. For our wiring, we'll also be using a light fixture. This is a 0 to 10 volt dimming fixture. We've got a black line for our line load in, our white for neutral, and then we have our purple and pink control lines. Some of our wiring will just be switching on-off only, so for those we'll just cap those wires off. Alright, so for our first wiring setup here, it's going to be a very basic low voltage sensor setup that's just auto on, auto off only. So for this wiring, we've got our light fixture, we've got our power input source, our low voltage aux sensor, and a power pack. We're using the OPP20-0D2, but you can also use an OD1 for this as well too. So I'm going to explain how everything is going to wire together. For our wire connections here, we already have terminals on the end of this, and we're going to connect those to our power pack. So our power pack has got multiple line voltage wires on one side. We're going to take both the blue and the black, and I usually grab the two that are together here, and those are both going to tie directly into our line voltage input. So on our wire terminals here, we've got the brown line. That's essentially going to be the black line or the line voltage in. The blue is neutral, and then the green is ground. So on our line voltage input, I'm going to open a couple of these terminals here on our Wago, and then if you need to, go ahead and clean up your wire ends so they'll go into your terminals nice and cleanly. Plug that one in, and that one, and then we're going to have the other blue is going to be our load line going to our light fixture. So the black line here, we are going to tie those two products together. So I'll just use a two-way Wago here and make sure that's nice and clean here. Put one in. We'll put our other line in here. And then after we connect these, so we're just doing all of our line voltage connections first. Make sure you don't have any, frayed wires coming out the ends. We're now going to tie all of the neutrals together. So we have a neutral here, a neutral from our main power cord in, and then a neutral from our light fixture. So all the neutrals tie together. So we'll open up a couple of the Wago connectors here. Add one in from the light fixture, one in from the power pack. And we now essentially have our line voltage connections done. Since we're not going to be using these low voltage control wires, we're going to go ahead and just terminate those with the Wago. Oops. One in. We'll do the same for the pink. All right. Next we'll be doing the low voltage wiring from the aux sensor to the power pack. Most of this wiring is going to be pretty straightforward where you're matching color to color. We're not going to be using the gray wire. That's a photocell wire that you can sometimes connect to a photocell directly from the aux sensor. We're not going to be using that for this diagram, so we'll cap that off. We'll go ahead and connect red to red. Red is the plus 24, so this is what actually gives the power from the power pack to the aux sensor. We'll connect those two wires together. And then there's the black, which is the negative 24 volts. We'll connect those two together. And again, if your wires are a little bit frayed, go ahead and just wind them tight so that they fit in there nicely without any frayed wire coming out. And then lastly, we'll have the blue signal wire, which is here. Go to the solid blue wire, not to be confused with the blue and white. That's your manual switch input. So we will tie those two together. You can even use a three-way Wago on these, even if you're just connecting two wires. You'll basically just only use two of those slots for your wire. And then there's going to be a couple wires that we're not using on the power pack. We'll just go ahead and use a Wago to terminate those wires. And then what we'll do, before we plug it in, let's just make sure everything, all of our terminals are nice and snug. Again, we're going to be dealing with line voltage here, so we want to make sure, for safety reasons, that everything looks good. And so next we'll go ahead and plug this in, and we should see the light fixture turn on, which it does. So there's a couple different ways we can now test this to make sure it's going to operate how we want it to. In this application, it's just basically auto on, auto off. So what we can do to test the sensor to make sure it's responding appropriately to occupancy, we're going to change some of the settings on the device. So let's go ahead and lift up the cover here. Then if you refer to slide 19, a couple of things we're going to do for your PIR. The default setting is at about 75%, but we want to make the sensor basically turn off as soon as possible. So we're going to reduce the PIR all the way down to the minimum, and to do that you're going to take the red dial and turn it all the way as it'll let you allow counterclockwise. So it'll be about a half to a quarter turn or so. Don't force it once you feel it stop, or you could damage the knob or the pot. And then for the ultrasonic, we're going to do the same thing. We're going to go ahead and turn that all the way counterclockwise as much as it'll allow us to do. We're not going to worry about the photocell setting for this. That's used for ambient light hold off, which for this wiring we're not going to have any effect on the sensor, be based on the amount of incoming light. And then lastly is going to be the timeout dial. Default position on that is to be at about 20 minutes. We want to turn that all the way counterclockwise so that it'll turn off at 30 seconds. So again, all the way counterclockwise until you're no longer able to turn without forcing it. Now, if you refer to the next slide, slide 20, there's a couple things we're going to want to do here. We want to put it in a PIR only mode so that when we test it, it'll be easier to get the sensor to turn off, or we just have to block the PIR signal. And then we'll want to make sure a couple of other things are disabled too. We'll want to turn off auto adapting. We'll want to turn off the walkthrough mode and make sure it's in auto mode. So for that, you'll first go to bank A. If you're looking at your sensor this way, you have bank A on top, bank B on the bottom, and your dip switches pointing down will put them in the on position. So for A1, we want that to be in the on position for single tech. For A2, we want that in the off position for PIR only. For bank 3 and 4, we want both of those in the on position, which will actually disable both auto adapting and walkthrough mode. So they're in that position now. On the B bank, the lower one here, we want basically just to be in auto mode, so that should be in the off position, which it is. And then we also just want to keep the override mode in auto as well too, so that'll be in the off position. And then your last two, which is test mode and disabling LEDs, we'll go ahead and keep our LEDs enabled, so both of those will be in the off position as well. So now to test the sensor, we'll go ahead and put the cover back on, and you'll need some type of cover to block the PIR. We have a bowl here, and we'll cover that up, and in 30 seconds we should see the lights turn off. So after 30 seconds, the light turns off, and then if we remove the cover, the light should immediately turn back on as it's going to sense our motion. So we've now confirmed that our wiring is done correct. So this would be a classic setup just to do basic on-off occupancy sensing controlled lighting. Common applications for this would be open office space, conference room, again in spaces where you don't need to have that manual control. Lights will just turn on automatically when occupancy is detected, and then they'll turn off when a space becomes vacant and the timeout expires. All right, for our next one, we're going to add a manual switch input to this setup, so we'll go ahead and remove power. and then we'll refer to slide 22. So we have the basic auto on, auto off setup, but now we're going to add a switch. In this case, it's just the PLVSW, a low voltage switch, to also give manual control to this setup. So a couple of things we're going to do here. For one, we're going to access the red wire. So I've changed out the WAGO from a 2-way to a 3-way. So we're still going to have those two same connections here. And then I have a third wire that I'm adding in. We'll go ahead and connect that to the WAGO. And then we're going to connect that to the positive input on the back of the PLVSW. This little Phoenix connector comes out, and you'll just want to keep track of which one is positive and negative. Since I just removed it here, I know it's the top one. And also, it's not a very deep connector here, so you're going to want to keep your wire fairly short so that you don't have any extending out beyond the terminal. And keep it all snug and tight in there, and it just has a screw that you turn all the way over to make it nice and snug. Now I'm going to grab orange yellow wire. This is the local switch input. Now in this application, it's still going to be auto on, auto off, so we're not going to use the blue white wire. That is what you would use if you wanted it to be manual on, auto off, where you would need to press the button in order to turn the lights on. So we're going to have it just be so that lights still come on automatically, but you can manually control it. So we'll remove this WAGO, and that's going to go on the negative side here, which is this side, and we'll go ahead and tighten that up. And then plug that back into the connection on the back. And again, just want to confirm no exposed wires. Everything looks good, and we'll plug it in. So light will now automatically come on, but with our switch, we'll have manual control. All right, so now we've got our same basic setup here. We've got our light fixture, sensor, power pack, and a switch. And we're gonna add another component to this system. What's nice about the low voltage sensors is that it's sort of a la carte. You can keep adding devices as needed per the space or as needed to meet code. So in this case, we're now gonna add Photocell so that we can do full daylight harvesting. Now, one thing I already did, I did switch out our OPP20-OD2 power pack with an OPP20-RD4. The only difference is that the RD4 also has a photocell input, and that's what you would need if you want to do full daylight harvesting. So our photocell is the ODC0P-D0W. The ODC0P-D0W can also do 0 to 10 volt dimming, so we do have those 0 to 10 volt dimming wires here too that will connect to the fixture. So first, we're going to take the orange wire, which is the photocell wire, and we're going to connect that to the gray photocell input on the OPP20-RD4 power pack. So we'll connect that in. Now, while these two colors don't match, gray to the orange, all the rest of our wire connectors are going to be color matched, so it makes it pretty easy. So we'll go red to red, and I also went ahead and switched out our connector to a 5-way WAGO because we're going to have 4 wires coming in here. And so we'll just make sure that wire is nice and tight. And we've got red to red, and that's going to be the positive 24 volts going to the photocell. That's going to power it. And then we've got the black negative or common wire that's going to go back to tie in with the other low voltage black wires. And that's important, low voltage, not the line in voltage black wire. It's going to be the low voltage side. And then lastly, we've got the purple and pink wires. These are going to go not to the power pack or the aux sensor, but they're going to go directly to the low voltage fixture wires. So we've got pink to pink, and then we will do, and the pink is the negative, and the purple or violet is the positive. And again, once we get this in there, we're just going to make sure all of our wires and terminals look good. So we'll now have the ability to have auto on sensing, manual control with the switch. We could also have a dimmer here too, and then we would just tie in all of our low voltage wires if we want to have manual dimming. But for this example, it's just going to be switching only, and then we have our photocell. So we'll go ahead and plug it in here. We should see the light come on. You'll also notice a light comes on in our photocell to show that it is energized. And then we'll just confirm that our switch still works. Now there's a couple ways you can test the photocell. We won't do it for our demonstration here today, but once it's calibrated, which you can either do manually or auto-cal, you can then shine a light inside of the photocell and it should cause the lighting to dim based on that incoming ambient light. So again, we've gone from a real basic setup of occupancy, auto on only, adding a switch for manual control, and we're now added a photocell for dimming. For the last demonstration that we'll do next, the low voltage setup is add another power pack and a receptacle so that we can also do plug load control as well. All right, for our next wiring application, we're now going to add plug load control. So we've kept everything in here, our sensor, our power pack, our photocell, our luminaire, and our manual switch. So next, for plug load, we're going to add a power pack. In this case, we've got the OPP20-OD1, which is just auto on, auto off. That's how plug load operates. It comes on when a space is occupied, and it turns off when it becomes vacant and the timeout expires. So we only need an OD1. And we need a separate power pack for plug load because it's going to be on a 20 amp dedicated circuit. So to meet proper NEC code, we have to have a full 20 amp rated product for that circuit. So we'll use the OPP20-OD1. I'll also be adding this controlled receptacle. This one, both of the outlets are controlled, but it's also really common where you'd have one outlet that's always on and one that would be controlled based on occupancy. So for this one, we're just going to use the double controlled receptacle or duplex type. And then because we're going to have live terminals on the side, we'll need to put the receptacle in a box just for protection there. So I've also going to be adding in a couple of wires just to make this a little bit easier. So first I'm going to go ahead and put these wires, attach them to the screw terminals on the back of our receptacle. So you've got the silver screw side, which is the neutral, and then you've got the brass side, which is the line voltage in or black. So just to help give us a little more room, I'm going to take these extra wires. and we'll add them in to the back of the receptacle here. Make that nice and tight, and you can feed it right through the back there. Try and make that as clean as possible. And then we'll just tighten that down. Again, make sure it's nice and secure. And then with my extra white wire, and again, we'll tie these into some other wires here shortly, but just to give us a little more room so it can be fed through the wall box. Give us a little extra slack there. So we've got the white on this side. Screw that down. Make sure they're nice and tight there. So next, we're going to go ahead and put this in the box. So we'll feed our wires through the back end here. Like so. And then I'll go ahead and place this down here, and we'll tighten down our screws to hold this into place, our receptacle into place here. So now we've got our receptacle, and we've got the hot and the neutral wire coming in here. So I've got our extra power pack. We're gonna go ahead and tie the black and blue that's on one side to the line voltage input. So from our initial plug coming in that's also attached to our other power pack, we'll go ahead and tie it in there. Now, let's say the lighting is on 277 volts and the receptacle, of course, will be at 120. You would have one power pack, the one for the plug load, attached to the 120, and then for your lighting, this one would be up above in the ceiling attached to the 277. And you can have the two voltages be independent of each other because they're only going to be connected to the sensor on the low voltage side, so it's going to be isolated from those two different voltage types. So it's okay to mix and match as long as you just have one power pack for one and one for the other. So we've got that now tied to our line voltage. We're going to take the neutral wire, connect that to our main neutral connection here from our plug here. And then we're also going to take the other neutral that's coming out of the back of the box to the receptacle for our receptacle control, and that's going to go into this last slot here. So we've got all the neutrals are essentially tied together. Now your line voltage, this is coming from your load wire from the power pack. So when the power pack receives a signal from the occupancy sensor that the space is occupied, it's going to close the relay and provide energy to the receptacle. So it's only going to do that when it's connected through the load line here though. So it's not getting your main power in, it's through the load line. Okay, so we've got all the high voltage or line voltage wires connected. Now we've got our low voltage connectors on the other side. So in this case, we're really just going to be mostly color-based here. The red is actually going to stay just closed off on its own. The red, since we're not going to be feeding anything out here low voltage wise, it's going to come on the line voltage side, we just cap that off. The black is going to tie into the black common or negative 24 volt on all of our low voltage connections here. So I did update that with a 5-way WAGO. We'll attach that. And then our last connection is to the blue signal wire from the aux sensor. So when a space is occupied, it's going to send a signal to the power pack to again close the relay, energize the receptacle. So we'll tie that one in. Again, we'll just kind of check and make sure all of our wires are terminated properly here. We don't want any exposed wires. And then we'll go ahead and plug this in, and we should see the light turn on. Now, to test our receptacle, I've got a night light here that I'll go ahead and plug in. It's in the off position right now. And we'll turn that on so you can see it's also turns the light on. So the aux sensor sees motion in the space, and again, it's now turning on both power packs. So with our manual control, we can turn the lights off, but our plug load is only based on occupancy. So as long as there's movement in the space, this will stay on even if we manually turn the lights on or off. So that way plug load stays on, only turns off when the space becomes vacant. So to go ahead and test to make sure that it's going to turn off when the space is vacant, we will cover up our aux sensor and let the 30-second timeout run down, and we should see both the light load and the plug load turn off. And as you can see, both the light load and the plug load turn off. If we open it back up and fixture turn on, which it does.